Unit 5, Relationships in Triangles. Lesson 5.4 is Inequalities in one triangle. Objectives. Prove that the side lengths of a triangle are related to the angle measures of the triangle and use the angle measures of the triangle to compare the side lengths. We're also going to get into Triangle Inequality Theorem to determine if three given side lengths will form a triangle and find a range of possible side lengths for a third side given two side lengths. Triangle inequality theorem. Let's start there. A triangle exists if the sum of the two shorter sides is larger than the third. So sum is when you add them together. So we have the lengths of the two shorter sides. And if we add that together, it should be more than the third side. So that first example there, if we have a side length of 5 and then two side lengths of 2, if we try to get those 2's to touch, it's not going to happen. Can't form a triangle. What about the 5, the 3, and the 2? The only way the 3 and the 2 are going to touch if they're laying flat on the 5, and then that's not a triangle. But if we have side lengths 4 and 2, they are going to touch before they fall down on the 5. So yes, that can form a triangle. So determine if the following side lengths could form a triangle. Prove your answers with inequalities, show all work. So I always like to find the longest side. They isn't always listed first. So if we add the two shorter sides, we get 25. 8 plus 17 is 25, and 25 is more than 24. Yes, we have a triangle. Longest side is 7, but 3 plus 3 is 6, and 6 isn't greater than 7, so that's a no. Longest side is 35. If we add those together, 12 plus 25, the shorter sides, we get 37, which is indeed more than 35, so yes, it's a triangle. Longest side's 52. If we add the 37 and 42, the shorter sides together, we get 79, which is definitely more than 52. So yes, it forms a triangle. Let's do some more. Longest side's 50. Two shorter sides add to 50. 50 is not greater than 50, so that's a no. Longest side's 18. Add the 6 and 14, you get 20. 20 is more than 18, so that's a yes. Longest side's 24. Add the 12 and 11 together, the shortest size, ooh, that's 23. That's not more than 24, so that's a no. Longest side is 41. Add the 7 and 35 together, you get 42. Yes, that's more than 41, so we have a triangle. Finding a range for the third side. Here's some examples. Given two sides of a triangle, you can set up an inequality using the sum and difference. Sums, the answer to an addition problem. Difference is the answer to a subtraction problem, so we're going to be adding and subtracting to show the range of possible lengths for the third side. So I don't know why I always add them first, but 14 and 22 is 36. That's the upper end. Can't be 36, but that is where it stops, just short of 36. And if we subtract, we get 8. So the third side could be anywhere between 8 and 36, not including either one. Let's do the same thing for problem number 10. If we add them, we get 59. Subtract them, we get 3. So anywhere between 3 and 59, not including 3 or 59. Add them up, 14. Subtract them, 8. Third side for problem 11, anywhere between 8 and 14, not including either one. 12. Add up the two values, 64. Subtract them, 26. So the third side's anywhere between 26 and 64. Number 13. Add them, 31. Subtract them, 17. Anywhere between not including 17 and 31 could be the third side of our triangle, number 14. If we add them, we get 25. Subtract, we get 9. Anywhere between 9 and 25 would give us a third side. Can't be 9, can't be 25. Do it again. Slightly different. Given two sides of a triangle, select all possible lengths. So let's get our inequality first. So I add them first, 42. Subtract them, we get 12. Anything between those, not including either one, but between them. 34 is between them, yes. 12, no, it's too low. Remember, it can't be equal to 12. It's got to be just above it. 29 works. So does 18, but 43 is too high. Find our range. We have to add them and subtract them to get our range. So anywhere between 36 and 54, not including either one, will work. So 35, too low. 58, too high. 47, that works. 54, too high. 39 works. Ordering angles in one triangle. The angles of a triangle can be put in order by comparing the sides. The smallest angle is always opposite the shortest side. The largest angle is always opposite the longest side. So we're going to order the angles in triangle ABC from least to greatest. Shortest side is 7. Opposite that is angle A. Medium or middle length is 10. Opposite that is C. And longest length 13. Opposite that is B. Order the angles by angle measures from least to greatest. Shortest side 17. That gives us M. Middle side 20. That gives us P. Longest side 24. That gives us N. Let's do it again. Shortest side 30. That gives us T. Middle side 35. That gives us R. And 38. Longest side. That gives us S. We could do the same thing with sides. Sides of a triangle can be put in order by comparing the angles. The smallest side, guess what, is opposite the smallest angle, and the largest side is opposite the largest angle. Order the side lengths of triangle DEF from least to greatest. Make sure you pay attention. It is almost always least to greatest, but sometime it might be switched. Ooh, we need all three angles. We don't have all three angles, but we know triangle angle sum theorem, so we can find the third angle. You need all three. So 180 minus 103 minus 42 gives us measure of angle F, and measure of angle F is therefore 35. Put it in the picture. Smallest angle is that 35, and opposite side is DE, or it's angle F. Cover up the angle. It's the other two letters. Segment ED, middle is 42. Opposite that is segment DF. Longest side is opposite the biggest angle, and that would be segment EF. Let's do some problems. Every single one only has two angles. That's okay, we know what to do. So we're going to take the 31 and 57, the ones we know, away from 180. We get our third angle, put it in the picture. Smallest angle, 31, shortest side, KL. Middle angle, 57, opposite side, JK. Largest angle, 92. Opposite side is JL. Find our third angle. So subtract the 2 that we know from 180. We get 59. Put it in the picture. Smallest angle is 53. Opposite that is segment ST. Middle angle is 59. Opposite that is segment ST. V. Largest angle is 68. Opposite that is segment TV. Get our third angle. 180 minus 82 minus 54. We get 44. Smallest angle opposite side is XY. Middle angle opposite side is YZ. Largest angle opposite side is XZ. Here we have a triangle again. Yes, we do have two of the angles. That is a right angle symbol, 90 degrees. So we have two of the three angles. The two acute angles of a right triangle are complementary, which means they add to 90 degrees. So if we subtract the 44 away from 90, we get that other angle, which is 46 degrees. Put it in the picture. Smallest angle, opposite side, is the shortest one, segment DE. Middle angle, opposite side, middle side, segment BD. And of course, the hypotenuse is the longest side, segment BE. That's the conclusion of lesson 5.4, inequalities in one triangle.